Hello everyone, I hope you're doing wonderful. Today I want to explain about my cybersecurity project. My project is about deploying IDS, IPS using Snort and pfSense. In this project, I want to perform some role-based threat detection to observe and evaluate the performance of these systems within my home lab environment and mitigate risks. Before further ado, let's get started. This is topology of my project. We have the globe is as an internet, outside internet. So in this project, we are going to conduct some attacks from the attacker virtual machine Kali Linux with this IP address to our target machine, which is a Windows 10 with this IP address. So all the traffic going through pfSense fiber router and going to be sniffed by a Snort IDS IPS. pfSense fiber router has two interfaces. One is WAN, one is LAN, and gateway for all internal devices is 192.168.1.1. This is the IP address for Snort, but the IP range that Snort is going to sniff is 192.168.1.0, which is a classless interdomain routing that shows the range of IP address that Snort is going to listen. In this case, Snort is going to listen to all the IP addresses starting from 192.168.1.0 to 192.168.1.254. I'm going to start on all the VMs inside the VirtualBox. They are divided into two groups. I have pfSense here, Fiber Router, Linux Mint, Windows 10, Kali Linux. I have installed Snort inside the Linux Mint. Windows 10 is for our target, and Kali Linux is our attacker machine. So all the VMs are running. We have here pfSense, and pfSense has two interfaces. One is WAN, one is LAN. WAN is for outside network, LAN is for internal network, and their IP address are written here. We have here Kali Linux, our attacker machine, and also we have here the Windows 10, our target machine, and Linux Mint, which first I'm going to install Snort. For doing that, I'm going to use sudo apt install Snort. Now that we install Snort, I'm gonna see the files. I'm gonna list all the files in Snort config directory with detailed information like permission, ownership, and timestamps. And for doing that, I'm gonna go first to its directories. So for doing that, it's under etc directory, etc Snort. Then I'm gonna list all. Okay, we see all the subdirectories of Snort, which is this is the Snort conf is the main configuration file, which for Snort that shows all the defined roles and preprocessors and paths. This is the roles that came with the default configuration of Snort. Yeah, I'm going also navigate to roles to check what roles are available in default configuration, and for doing that I'm gonna use cd. First I'm going to its directory and I'm gonna list. Okay, so we see all the roles that came with the default installation of Snort. So we have here all the community roles, for example. We have here DDoS roles, we have here ICMP and FTP. And yeah, for example, I'm going to check on exploit roles because it's for exploitation. So usually it's for the vulnerability mostly. So I'm gonna first see how many roles we have in exploit roles, and I'm gonna use cat command exploit roles. Okay, yeah, we have here many roles for exploitation. It's usually for the when attacker wants to take advantage of a vulnerability in software or operating system or services to gain unauthorized access. They created these rules to prevent such a vulnerability in operating systems or services. Yeah, there are many roles here, and these roles have been created to detect known exploitation attempts. Yeah, for example, this is a alert to this is the protocol DTCP, and from external network, this is the port to any port. So this is the direction to inside network, and this is the port. The message here says exploit SSH CRC32 overflow. It looks like it's old SSH which had vulnerability, and they created this role to prevent the vulnerability that we had in SSH communication, and also a CVE, which is common vulnerability and exposure, which was in year 2001, and this is the number, class type, signature. They have also signature and also revision. So it was vulnerability. Okay. Now, first I'm going to list. Okay, again list. Okay. So after installation of Snort, I have to check on some configuration. So for doing that, I'm going to write sudo nano. You can use any other text editor. It's under etc directory snort snort.conf, and the name is snort.conf. All right, you see here the configuration file, which is the heart of Snort configuration. From here we control everything in Snort, such as network variables to role sets and output plugins. They're divided into different sections here, like decoder, preprocessor, dynamic libraries, rule set. For the variables, I have already set the IP range here, which I have explained in the beginning. So this is the IP range that this node is going to cover. And for external network, it's set to any, which is good. All right, we don't do any other thing here. So we are going to go out from here. So, okay, for the next part, we are going to check on the configure whatever we change in the configuration file. So we have to check on validation. For doing that, I'm going to write sudo snort T for test, and also we have to write the path etc snort.conf. We got the message here, snort successfully validated the configuration. So every time we change something in configuration file, we have to check that it's validated and we are good to go and work with our snort. Okay, next I'm going to check on the roles, because for the sake of this project, I'm going to write some roles in a Snort in order to conduct some attack from attacker machine and see how Snort is reacting and sniff the packets. For doing that, I'm going to go to local roles, because that's in under directory of Snort conf. And for doing that, I'm going to write sudo nano etc snort local rules. All right, this is local rules here, which is empty. We don't have any roles here, so we can write our customized role here. Snort could sniff based on the rule that we set for the snort. Okay, I'm going to write a rule here. Alert ICMP. That's the source IP address we wrote. So this is ICMP from as a source IP address, source port. So towards our homenet, our network, to any port. So this is the message. Unique ID also. So it has units 1004. Now we save it. So for validation, I'm gonna write sudo snort. This is the direction. It's an etc directory. Snort, which is all the file for configuration is snort conf. So this is the test node. Configuration is not successfully validated the configuration, which is everything is good. So our role is active. It's gonna work. Now we are going to run this node in sudo mode, in root mode. So we're gonna write sudo snort A for alert. It's showing the alert on our console or the screen. And then in our console, we use Q for quiet mode, and also we specify the path, etc, snort. So the interface is going to listen to, it's going to sniff. In my case, so it is ANP0S0S3. Okay, so when we get this one, it shows that this is running. It's running. All right, so this is the Kali Linux. We're gonna ping to Windows 10, which is the IP address is this one. So I'm gonna write ping 101. Okay. Okay. So we are pinging from our attacker machine Kali Linux to Windows 10, and we already seeing the alert message in our Snort is showing ICMP detected, the way that we wrote on the role in local roles. So ICMP detected. So this IP address, which is the IP address for the Kali Linux 101, and which is pinging to 100, 192.168.1.100, which is the IP address for Windows 10. So we are seeing all the alerts because it's pinging right now. I'm gonna stop it. Okay, I wrote another role for port scanning, alert, TCP protocol. This is the source IP address and port IP address. And this is the home net, which is, this is the direction, and this is the home net, which is our network. And this is the port. So for the message, I wrote port scanning detected. I also put flags for that, flags, which look for SYN packet, which is typically used to initiate connection. Unique ID 1005 and revision. So we are going to save that, and then we are going to validate in local rules. We get this message, it's successfully validated, and the rule is active. Now we are going to run Snort. So this is the command for running Snort. A console, display the alert in our console in quiet mode, Q quiet mode, and this is the path etc snort.conf using this configuration, and also interface. This is my interface. This is active. IDS is active. So we are going to conduct port scanning attack from Kali Linux using nmap -ss is stealthy and fast port scanning. P for port, which I put from 1 to 100, and our target IP address is for Windows. Yeah, let's do port scanning on Windows 10. Okay. Now we see IDS is working and giving us alert. Port scanning detected based on the role that we have written in local roles. This is the IP address of machine that attacking, and this is the IP address of target. So the way that we have written on our role. All right, this is another role for HTTP exploit that target vulnerabilities in web application or services using HTTP protocol. And by HTTP exploit, a threat actor can gain unauthorized access, execute malicious code, and steal data. So this uses TCP, the source IP address, source port. This is my home net, and since it's HTTP, it uses port 80. And my message here, SQL injection, unique ID 1006, and revision 3. So I'm going to save this. I'm gonna validate also configuration file. Okay, when we get this message, it's successfully validated. So we are good to go. So I'm gonna run the IDS snort. So this is the command. I'm gonna run the snort IDS in console mode. We get the message in console and running. I'm gonna conduct attack from the Kali Linux. So this one, the QRL HTTP, it's sending GET request to login page This is a query string that after question mark, there are some parameters that pass to the server, and it tries to manipulate SQL query on the server. There is OR here, which is an OR condition that always true and try to manipulate the server for login credential. So I'm gonna run this this command. So right now it's running. So we see, as you see, we get alert in IDS, Snort. So SQL injection and TCP. This is the source targeting our Windows 10. This is the IP address. So we are receiving the alert message in Snort. I'm going to check on the logs. Usually Snort logs in var log, so I'm going to use cd command var log snort. Use ls command to list all the logs. Okay, so we see all the logs have been stored here in the snort file. So I'm gonna use the cat command here to see one of the logs. For example, snort alert fast one. Okay, so we get the information, the log information about the alert and the priority and different the traffic that Snort is sniffed and logged for us. And yeah, I'm going to analyze one of the logs that captured by our IDS, IPS. And for doing that, I'm going to go to Files, File System of Linux, my Linux Mint, and then I'm going to var. From var, I'm gonna go to logs, and this is for the snort. So these are all the capture file, pickup files that by captured by our IDS, IPS. So I'm gonna, yeah, for example, I'm gonna analyze this one with Wireshark. All right, so this one is about the capture traffic by when we did the attack for HTTP exploit from Kali Linux to Windows 10, because I see the source IP address 100. This is the source IP address for Kali, our attacker machine, and destination 101 is our Windows 10. So based on this, I can understand that this is the TCP HTTP exploit attack that we conducted. And so overall, so we see many retransmission SYN packet. The SYN packet suggests that Kali, the attacker machine, is trying to initiate a TCP connection, likely to deliver the exploit. And we see also here incomplete SYN. Repeated SYN transmission indicate that the target either didn't respond or actively rejected the connection due to firewall filtering or service unavailability. So overall pattern here looks abnormal because these pattern repeated SYN, TCP retransmission, and failed connection attempts are the indicators of exploit delivery, confirming that our role in IDS is effectively capturing suspicious activity in real time. This was my cybersecurity project, and thank you very much for your attention.